This platform actually comes with an amazing developer portal. And in this video, we're actually going to start by exposing the application's API securely. We have this product page service running, and we are going to annotate the service of the product page to tell the platform where to find the Open API doc as well as your spec. You can see we give the URL for finding the spec, but it can just be specifically a path like /swagger.yaml. Then in that case, it'll just look at this path on the service itself. Now I'll go ahead and annotate the service, and we need to automatically create this API doc that is an object that is containing information about the spec and the service that is providing this particular spec. You see the service in this case is actually the product page service in the namespace in cluster 1, and this is the spec itself. Every time the deployment is going to be rolled out, it's going to update this API, because when you restart your pod, that means that potentially you have a new version of this API. You can also see later that you can also create this API doc manually by providing this information instead of having it discovered, which is useful when it's an external service. We have this API doc discovered, and now we want to expose it. So again, we use a route table like we've done previously for all other applications, and we are just going to add this portal metadata, which is not going to be used now, but we are going to take advantage of it a little bit later on. Then what we need to do is we need to expose these APIs through a prefix, API book info, but really, or in reality, the backend is expecting API v1 of product. We use this path rewrite to make sure that the backend service is going to receive the request with the right path. Then we apply some labels as well, because we want to secure the requests with API keys, and we also want to apply some rate limiting there. We also want to use some transformation later based on this API product page, but again, it's not really important right now. We'll speak about it in another video. So I applied this route table, and now I can access the API. And right now it's not protected because I didn't create any policies that I need to match specific labels. So that means I can go ahead and access the API, and rewrite is working correctly in this scenario. So the next step is about securing this communication. And what we'll need to do is create this xauth policy like we did in another video, where we enforce authentication with OIDC. But in that case, we are enforcing authentication with API keys. Then you see that we will say that the API keys are going to be stored as Kubernetes secrets, and we're going to create a new header called xSoloPlan from this metadata name. This metadata has the name plan in the Kubernetes secret. If I apply this policy, I'm going to secure the traffic with this API key. I'm going to specify the x.server that I want to use. Again, I just have one x.server because that's what people generally do in their environments. Now, if I have to try to access the API like I did before, I get a 401 because the API key has not been sent. And that implies that I'm not authorized to send this request. I need to create the secrets like we said before with this value of API key, which is encoded with base 64. That's my key. And you see this plan, and the plan here is basically the base 64 value for gold. And that metadata is going to be extracted by our policy like we have defined here. We will have this xSoloPlan header, that will be created automatically with the value gold. So I created this environment variable and the secret, and after that, I can send my request, but this time providing the API key. So if we give it a few seconds, we can see what's actually going on here. And you can actually see that it works because I have access to this API, but it's done securely. As I mentioned previously, user 1 is a gold plan user. So we are now going to create rate limiting based on this X solo plan. The X solo plan header has a value gold in my case. We are going to create this descriptor key usage plan based on this header. Let's take this and create a policy so that we say we want to apply a limit of 5 requests to the users that have this plan set to gold at the moment. But we have different limits for different plans, so this can be very useful, especially when it comes to billing. Instead of doing a billing per request or a per billing request, which is something you can do, we can speak about monetization inside of another video. Here you can do a very simple billing, which is you choose the plan you have for different pricing for either bronze, silver, and or gold based on your requirements. And you can send some requests until you reach a limit, and that's a pretty popular way to do billing inside of the API world. Let's apply this again, and you can group everything together in this ready-made policy. And say you want to do this after authentication because you want to take advantage of this X user plan that is created by the XDauth policy. Then what you can do is define your rate limit server again. We only have one, and that's what, like I said, people generally do because it's flexible. You can have many if you want to, and that's fine. I can try to send this request 10 times, providing the API keys so that my user is correctly authenticated. And I should see some 200 responses at the beginning. Then after 5 seconds, I should start to see 429s, which you're able to see. And after 5 successful requests, then I am basically rate limited.